Hi, this is Bob Cummings again. We're to the third phase of our process, and this is to define, to create a definition and to understand what components require what characteristics. We know that in the interface between our test subject Ted and the mechanism that we're going to use, the vehicle that will carry the therms from Ted into the ground, that we know that it should have a high thermal conductivity. Well, how do you know if it has a high thermal conductivity? Thermal conductivity and electrical conductivity parallel each other very closely, so we're going to use that as a baseline. We can use metals, which is going to have a higher thermal conductivity and electrical conductivity, and our flexible components between our subassemblies are going to be required to be made out of plastic or as simple as a rubber hose. We know that these components have a very low thermal conductivity or electrical conductivity. These values can be found in the machinist's handbook and different scientific textbooks, and simply if you take a multimeter and put it on resistance, you'll be able to determine one from the next and which is going to work better. And we should also determine the fact of insulation versus isolation and how thermal conductivity interacts between the two. But basically what we want to look at is the areas that we need good thermal conductivity. We need that to function efficiently between Ted and the vehicle, which would be the water. The interface more than likely will be metal, and by the time we get underground, we want to be able to strip these excess therms and shed them in an efficient manner. So most likely the components that are going to be buried need to be of some metallic state.